So in this video we will create 1D ICM model. Basically we have to transfer the 1D HEC-RAS model into ICM. Let's see, this is geometry we have created, 1D river, okay, and the cross section. All right, we will transfer, and one bridge is also over there, okay, as you can see over here. And we will transfer this model into ICM. Okay, let's see. Okay, first of all you need to check what is the project file, this channel modification PRJ, and the geometry file name dot G01. Okay, so go to your ICM, okay, and just create the network. Cross to ICM and put 1D across to ICM. Okay, then just open your model. Okay, put your DM. Okay, to the ground. Right, then go to your network, go to import, go to model, go to your HEC-RAS network data. Okay, so our file is located in this folder, and we have to find first PRJ file, projection file. So this is our projection file. You need to match it, modification channel.prj file. Okay, then open, and it will automatically open it, and it will ask you again geometry file. So we have geometry file, this one. You need to match it. This is your geometry file. Okay, so just open it. So you will see your cross section and your bridge has been located. Okay, right, so you need to see. Yeah, in HEC-RAS it is very difficult to create the end cross section, but in ICM you have to create the end cross section, right? And it is automatically created the nodes also. So you can put node 1, rename as per your requirement. Okay, I'm just assigning this name because I have created the inflow data and assigned the profile N1, so that's why I'm just creating. Okay, I'm just changing it, N2, N3, this will be outfall. Okay, so now you need to change the name. Out, you need to change the node type is outfall. Okay, later we will assign the uh, ground elevation. Okay, so we need to create the end cross section line. Okay, so here cross section line, it should be matched from the end of the ridge. Okay, double click, it will be TS, not this would be cross section line. Okay, this, yeah, later we will define it, the meaning value. One and cross section line we have to create over the errors. This is upstream cross section. All right, now you need to just select whole network and go to the model, update the ground elevation. Okay, so this DH is that terrain. So we have updated these cross section lines. All right. Okay. Now you can assign the grounds. It is coming 200 meter. So you can assign the outfall elevation is 200. Okay. Yeah, one thing you have to assign the meaning value to this. Assign it set 0.045. Okay. Rest of the cross section you have already defined the meaning value in your HEC-RAS model, so you don't need to redefine. All cross or rest of the cross section has meaning value. All right, you just need to find it for this one. Okay, set 0.045. All right, yeah, so you need to see the elevation. What's the elevation is coming 206. Okay, so you can assign the elevation 206. All right, same thing you have to 203.695. Copy that elevation and assign it over there. Same thing you have to do this one 203.586. So that assign it. All right. Now you have to do select your whole network. Okay, just deselect your bridge section, this approaching section and this. Okay, and rest of the section you have to just go to your model, go to reach and click on build all. Okay, just build all. So it is showing that no banking station were identified. Banking station just will be required when you are going to combine your 1D with 2D catchment. Then it will create. Okay, because we are just creating 1D model, that's why it is not creating bank connection. Okay, yeah, for this one you have to see that maximum elevation is coming so you can make it 210. Select whole one and 210. Okay, so now this is perfect. Okay, yeah, now you have to in this ICM you just need to one thing you need to do, just you need to create the openings. Okay, select line and create opening upstream to downstream direction. Change it to bridge opening and put it opening. All right, yeah. So first of all you need to select the shape, what kind of shape it is. Yeah, rectangular. Okay, and width you need to check what's the 190 meter, 190 and 190. Let's see, we can put 170 meter and 6 meter height. Okay, meaning value 0.013 for the concrete bridge. Okay, now it is asking for the elevation, for the upstream elevation. So we need to see what's the upstream elevation 20656. Okay, go to and downstream cross section elevation is 20 3, 6 to 5. All right. Yeah. Okay. Now you have to come to our pairs. You need to locate the pairs. Okay. So over here you need to create one pair, and we will put minus 60 over there. It will show that the distance 170 meter, 65 minus uh, uh, minus 85 this direction, minus 85 this direction. Okay, so that's why minus 43 minus 24 0 5 26 40 and 7 will be sorry 60. Okay, now we need to define the elevation. So we are just thinking 203.6 meter elevation will be in between 20 to 5, but we are thinking that this will be the elevation. Okay, or we can put as a 0.063. Okay, all right, no problem. Just to meter width of the piers, and it will be concrete piers. So for many values will be 0.013, and you need to, yeah, paste, paste, paste. You just need to copy and paste to the rest of the column ID, piers ID. All right, so you all have these are kind of piers. Okay, and just click OK. All right, then just select your bridge and section, go to the bridge, click build section from lines. Okay, so your section has been created. Now go to your bridge again, insert selected openings into the section. So you can see this is the kind of error is coming, so we have to reduce the width. Then again you need to go to there and opening, so your opening has successfully inbuilt. Okay, okay, or you can visualize 3D to see that your openings. Okay, exactly, right. Yeah, so yeah, we can create the boundary also. So as you can see, this is the boundary of the bridge. Now you need to see the cross section. Yeah, this cross section is showing because we didn't define the discharge coefficient and modular limit. So we have a SQL query, so we can just put it over there. As you can see, error has been removed because SQL has that information already. As you can see, open it. So we have already defined the reverse discharge coefficient, and for the left bank and right bank, a modular ratio for the left and right bank. Okay, all right. So as you can see, it will also not show any error. Okay, there's no error. All right, now we have to just validate this model. Okay, you can see there's no error. Just save the model. All right, now you just need to check the inflow we have already created. Okay, so this is inflow. Okay, you just need to check the properties N1. Okay, this the object reference. This is the object reference should be then as it should be the same name or this name, the pure this inflow name should be in your inflow HEC-RAS inflow data. Okay, then you just need to go over here and try to recreate the one, run dot 1D HEC-RAS to ICM with breeze. Okay, just put your network over here and just put your inflow data over here. Okay, make it 10 for 6 hours duration. We have this data. All right, and just run it. Okay, wait for a moment and it will complete. Okay, so as you can see, our model has been completely run with a small warning. Okay, so let's see how's our model. Okay, yeah, just need to go to the over there, open the flood depth, and just apply. Just wait for this one. This one. Okay, yeah, you just need to wait. It's just hanging problem. Okay, just wait. Alright, so as you can see, this the flood depth is showing. You need to click on maximum. So it's the maximum flood depth showing over there. You need to see the graph opening. What is the maximum flow? It is showing 454. Okay, or you can double click over there. You can see 454 is the maximum flow. Okay, let's check in HEC-RAS what is the maximum flow. Go to there and see that stage hydrograph. What is the maximum flow distance? 500. Exactly maximum 500 elevation is coming. Okay, it's okay. It's not a big difference. Over here is coming this much. Okay, flood depth is coming 2.54 meter. Okay, that's head elevation 206.308 meter elevation. In HEC-RAS it is showing how much? 208, right? Around 2 meter, maximum 2 meter elevation that is showing. Yeah. Oh, it's okay. Okay. Yeah. And you can visualize your cross section, like select that cross section pickup and come on and click on this type of cross section is appearing. Okay. This one, right? This is the cross section. Okay. For every cross section, you can see the graph. How much flow is passing through this one? Okay, this is the upstream flow and downstream flow that is passing. Okay, all right. So you can directly import your HEC-RAS model into ICM, so you can find out your results. All right. Thank you so much. I think in HEC-RAS I've used some different inflow. Let's check what was the flow over there. Flow hydrograph. What was? This kind of flow hydrograph. 500. In ICM, what we have used. Let's see. Uh, Open air graph. It is the same as 500. Same as graph we have used. Okay, that's not an issue. Okay, it's okay. Okay, or you can see the dynamic movement of the film because we are passing 10 cubic meter per second velocity in inertia. That's why, as you can see. Okay, all right, and you can also visualize. Select whole network and see the 3D view. And show of this one. This is a 3D view. This is your base, and this is the flow. Try to see the dynamic movement. When the peak is coming, the flow day go over this way. All right. As you can see, the water level is rising. Okay. Yeah, you can see it. Right. Thank you so much.